Welcome and good morning, everybody. I am very thankful for the friendly and correct and nice introduction, but I will add to this a little bit. But before I start, I have to apologize. I have to apologize for my weak voice, which is the effect of an operation I had a couple of months ago, and the nervus vagus is irritated, so I can speak only very slow and have no chance to cope with the speak yesterday. I don't even try to speak with half the speed of her, but I apologize for that. I have also apologized for my weak memory. Due to my high age, I'm getting 80 in a couple of weeks. I'm getting slower and I'm losing my memory. So please excuse for that. I can't remember anything. Then I have to warn you. Most of the slides I will present are taken with my digital camera and I have the copyright, and I don't care if you use it. But some of the slides are stolen from the internet. And I don't want to be claimed if you're getting into trouble if you publish that. Then I have to apologize for mixing informatics, mathematics, philosophy. I don't care. I think common sense is the thing to approach, and I really don't care how you name it. And I also apologize for the lack of scientific background in my performance. I don't want to call it a lecture, because the lecture will implies, the name lecture implies that there is some content to transform and to teach you something. I'm not going to teach anybody anymore. I'm just making a performance. And please lean back and enjoy it. So, I have the privilege of being the last keynote speaker. So I added a few ideas to my presentation due to the former presentations from yesterday and on Monday. To the topic of testing, and I think there are plus minus 1 errors, which are due to the fact that an alley, which it's also stolen from the internet, if you count the number of trees in an alley, it's always one more than the difference between the space between the trees. And this is a fundamental observation which applies to many of the errors we make, because it's just either one too much, one or one less than the thing you want to do. If you want to measure the length of the alley, you have to count the spaces in between. If you want to know how many trees there are, it's just plus 1. So be careful. Then somebody mentioned the Boolean algebra. Boolean algebra is something which is fundamental to our logic. And I recommend every teacher, be it in pedagogy or whatever, to understand Boolean algebra. Because the name Boolean algebra is shocking. But the content of Boolean algebra is so fundamental. Let me give you an example. And excuse my rather scientific wording. The implication X implies Y, which means if there is X, then there always have to be Y as well. And you can also express this with Boolean operators, and, or, and not. For example, it's the content, the semantic is the same if you say if X then Y, or if you say it's not X or Y, because the implication holds if the preposition X is not fulfilled, because if you don't, if there is no X, you can, it's always true, the implication, or if the outcome is true, if Y is true, then it's okay whether X is true or not. And there is a wonderful example, the full moon hypothesis, which most of you might know, the saying that if there is full moon, the weather will be fine. Yeah? And let's try that out. If this is a true implication or not. And there are 4 possibilities. If it's not full moon and the weather is bad, the story is okay, because it doesn't say anything if it's not full moon. If it's not full moon and the weather is good, it's okay as well, because it doesn't say anything if the preposition is not fulfilled. But if it's full moon and the weather is bad. That's, there might be an error in the hypothesis. But if it's full moon and the weather is good, it's fine. That's what we wanted to state. So, it's just simple logic. And I think this is fundamental, not only in informatics, but in our everyday life. So, now I'm going to switch the topic. Because when I gave lectures, thousands of lectures on computer science, introductory courses on the Technical University in Vienna, and later on at the University of Zurich. I always started my lecture either with a song or with a story. Because it's my firm belief that stories are essentially for pedagogic and for teaching. Joe Weizenbaum, one of the computer science pioneers, maybe, who knows Joe Weizenbaum? Yeah, of course. Well, I'm going to show you a picture later. He said, the only way to learn is by stories, by examples. There is no other way you can learn anything. So, because it would take too long to tell you a story, and I'm telling stories throughout my presentation anyhow, I present you a song. And please watch the lyrics, watch the wording. So here we go. So, it's called Joker Man, and Bob Dylan was asked who Joker Man was, and he said, it's a mystery. He doesn't name anybody who's the Joker Man. So, some people believe that it's me, that I'm the Joker Man. That's not true. I'm the Java Man, because I gave so many lecture programming courses on Java. And that's me. But if you remember the lyrics of Joker Man, maybe I can show them again. There is one thing I want to point out. It's freedom. Freedom just around the corner for you. That's great. But with truth so far off, what good will it do? So, if I can interpret that, It took me more than one sleepless night to trying to understand what that means. But when I woke up in the morning, I got the idea that I could give you so many examples with false, with fake stories, fake news, which are not true. And if the truth is gone, you can't do nothing. Freedom doesn't help you. So please, this is one of my takeaway messages. Please think about it. And I don't blame you if it takes also 1 or 2 nights to consider that. Okay. So, I want, it's everything about my CV has been said. By education, I'm an electronic engineer, so there was no computer science then, but I made my PhD in informatics in Vienna, and then moved in the 80s to the University of Zurich, and I gave so many courses, introductory courses on computer science, and continued. There are thousands of students who went through my courses, and I meet so many of them when traveling around. And of course, I can't remember everyone, but they are, all of them are very thankful for my lectures because it helps them on their professional career. There is one. It's called a long read. A long read in the internet. And if you're interested, either follow that link or Google my name Schauer and long read, and you will find an English presentation of my life. So, I showed to you that I had been called the Schauer man, and I just, well, I don't have to defend any scientific reputation. I had that in the past. Enough of this. So I'm free to show you some of my books instead of a long list of publications. I show you the invitation to the first computer camp in Austria. We organized that together with Gerald Fuchek, and we always combined it with sports or music or art, because to our experience it's important not to focus on programming. We did logo programming with kids and with adults and with kids of poor parents and kids of rich parents and kids from the kindergarten, where I'm very skeptical whether it's okay to give them a computer. But as soon as they go to school, it's fine. And also to adults, to old people. And there were, I didn't count them, but I guess it's hundreds of these courses. We founded a company and it was sponsored by the Austrian Computer Society, and I learned a lot from the kids. And, well, one of the experiences is that you always have to combine a computer education or computer use with something completely different. And it's also in one of the Bob Dylan songs where he stated, "What else can you show me?" I think that's important, to have, not to focus only on one point of view. I went to a number of, well, hundreds of conferences, and in some of my slides you will find this picture. It's a symbol for the butterfly in Brazil, causing a hurricane in Texas. You know the story of chaos. And, well, I believe in chaos as well. And I have no fear from chaos, because chaos is very fruitful, very constructive, if you know how to handle it. Well, the main... I have to hurry up, I have to speed up, to come to my topics. But you can read that, I don't want to comment at you. But I give you an overview. These are the pictures I'm going to show to you. And the first of them you have already seen. One of my very, very firm beliefs is that the speed of change, of technological change, is so fast that teaching teachers on technological issue doesn't make any sense. Because when you're finished to educate the teacher, the technology, it's the technology from yesterday. So maybe this is frustrating for many of you, but it's the truth. I show you some pictures. Windows, yeah, family tree. These are on a time scale. When you go back to the 80s, it's gone. And this is a picture of Windows versions which are not anymore supported by Microsoft. And it's not that past, because it's also versions which had been popular in 2008. If you educate the teachers, that doesn't make sense. So one observation is that technology changes faster than our educational system can cope with. This is one picture which is private. I made it with my Nikon. You see my daughter in a coach for the wedding. So the profession of driving a coach, which was for decades, even centuries, one of the important professions and means of traveling, is now just for fun, just for, well, it was her wedding. And by the way, you also see dogs. I have so many dogs. And there were all our friends, which had been invited to the wedding, brought their dogs. And we had several dog sitters. One of them is holding a dog there. There were 22 dogs. And it was chaotic because some of them wounded our guests. We had 3 accidents in the local hospital, and while my wife and me were bringing these people to the hospital, the other dogs ate up the buffet, and it was so chaotic, but it was fun. So, just for the fun of it. And the technology changed. But even this is just outdated. So, my take-it-home message, half-life of product-specific knowledge is becoming shorter and shorter and shorter. So, product-specific knowledge is important for continuing education, because there's really no sense in teaching the kids the things which are obsolete when they leave school. So, forget the handling of a computer. It is different tomorrow. So the only thing we can do, and we have to do, is to focus on conceptual knowledge in school. And this is what I want to focus on. The problem with product-specific teacher training is it's even more dramatic than I showed to you on the slides before. Because, well, I know what I'm talking about. Hasler Foundation is one of the sponsors of the conference. But Hasler Foundation also sponsored informatics education for teacher for the whole Switzerland. And it was me who was in charge of educating these teachers. Not personally, I had a group of assistants. But my experience is, when it comes to teacher training, first of all, you have to plan what you're going to teach and how you're going to teach. And this planning lasts at least 1 year. Then you have not to train the teacher, because there are thousands of teachers. It's a matter of quantity. You have to supply a team teaching the teachers. And this, to teach the team for teaching the teachers, takes at least another year. And the courses for the teachers took 3 years. So there's a time lapse of 5 years until the teachers are starting to teach. And there's not a single pupil involved yet. So it's crazy. What's the hurry? Joe Weizenbaum said. Slow down. But we can't slow down technology. So what we're gonna do is to concentrate on fundamentals and fundamental concepts. Well, whether you call it ICT, I call it informatics when it's focused on long-lived fundamentals. And what's called ICT is rather focused on application and is short-lived. So, what are these concepts? I give you a number of examples as long as I'm allowed to speak. And I'm just now starting with my presentation. One thing that to me is very important are the number, the orders of magnitude with numbers we are talking about. For example, 1,000 has 3 zeros. 1,000,000 has 6 zeros. 1,000,000,000, 9, and 1,000,000,000,000 depends on which culture you the names of these, be it a trillion or an American billion, differs. But this is just the name and not the meaning. So there are 12 digits. So whether you call it logarithm or not, it's the number of zeros that is important. And, well, in this, to you, I can call it logarithm. To kids, I wouldn't call it by any name, just number of zeros. But it's the logarithm, which is maybe a mathematical concept, I don't care. But it's important to informatics. And we can introduce names like kilo for 1,000 and mega for 6 zeros and giga and tera and so on. But this also goes in the negative direction. When it's 10 to the -3 power, it's milli. And -6 zeros is micro and nano and pico and so on. Etzke Dijkstra, I'm going to tell you a story now. And in fact, it's Edgar Dijkster's story. Edgar Dijkster is one of the founders of Turing Award winner. Turing Award is similar to Nobel Prize in Informatics. And he told a story to show the order of magnitude. If you look at at a baby, and it's going to move. So how fast can it move? Maybe a couple of meters in a minute, but it's rather slow. Look at another technology, like a supersonic airplane, and it's just movement in one direction. So from the physics, it's the same phenomenon, but a completely other technology and a completely other speed. And the order of magnitude might be it's a giga speed. So this is an illustration of what order of magnitude means. Well, when it comes to data, we have to distinguish be the signal. If I want to communicate, I send a signal from a sender to a receiver. That's the model. And the signal is transported by a medium. And let's say it takes microseconds from the sender to the receiver. But if I focus on the message, it takes milliseconds to transport a message. But to transport information, and I will in a minute show you what I understand under information, it takes seconds, because information needs an observer, and the observer has to process the message in his brain. And this takes some time, because we are humans and not machines. But to make this information to knowledge can take hours or days, depending on the situation. And from knowledge to wisdom, which is a rather philosophical remark now, can take years or decades, and some of us are not able to transform it to wisdom at all. So, the human brain has a capacity, if you just count the neurons, it's from the order of magnitude of 10 to the 12th bits. That's a fact. And if I may digitalize the human brain and compare it to the memory capacity, it's an interesting comparison. For we had 10 to the 12th on the human memory, and the genetic code is 10 gigabits, which is almost the same. So in nature, it's quite balanced. What we inherit when we were born, what we inherit from our parents, is almost the same information, quantity of information than what we can memorize in our brain in an average life. The funny thing is that there is no erase button. Our brain is organized in a way that it always adds content and never forgets anything. The invention of a delete button is not in the human evolution. And I was very much afraid when I learned this, that I remember too much, and this would lead to a memory overflow. So I tried to select what to remember and what not. But the brain is, the capacity of the brain is so redundant, is so much more than that it doesn't matter. You can remember anything. You just cannot access it. But it's still there. And under hypnosis or trance or in your dreams, you will remember. For example, the human eye compared to my digital camera. Well, 4 megapixel, that's so poor, yeah? Every handy has more. When talking about information, I believe in information theory developed by Claude Shannon, who defined the information content as, again, I'm sorry, I have to name it, the logarithm, base 2 logarithm, if you want to measure it in bit, from the inverse of the probability by which you expect this information. And this is important because it's individualized. The information content is different from person to person. And if I receive a message, I already know the probability that there is something new is 1. The probability that this message, not that something new, the probability that this message will be received. And there is no information at all. But the maximum of information content is when you have different probability, is when the messages are equal probable. So this is interesting. I'll show you a picture right now. But together with the information content comes the concept of redundancy. And I think redundancy is a very important basic common concept because redundancy might be very helpful if there is noise and you understand just a fraction of the message. The message in natural language is so redundant that you can imagine the meaning. So, but if the message is very rare, the information content is very high. I didn't find an English example, but this is the message in a newspaper, in an Austrian newspaper, that an Egyptian woman gave birth to 6 kids at once, which is a very rare event, and it's worth a headline in the newspaper, because regardless if you know the person, well, if I knew the person, it would be a much higher information content to me. Even if there is a chance that I would be the father of these 6 kids, I'm informed very much more. But even if you don't know this woman, the medium makes a headline. And there is the so-called Shannon, the inventor of the information theory and the information content, with the Shannon's function, which shows us the information content if there are only 2 possibilities. So you know the probability of the one event and the probability of the other event. The sum of them is 1, and there is a maximum in case the information or the message is equal probable. So now speed up. Thanks. But it's another story. When I moved to Switzerland, my daughters went to, I have 2 daughters. You've seen one of them. But there's a second one. They were elementary school kids, and we walked in Zurich, Bahnhofstrasse, and there still is a famous shop, Franz Karl Weber, with toys. Franz Karl Weber. We went there and bought a puzzle, 3x3 puzzle with turtles. But there is a number of literature on this so-called monkey puzzle. In the literature, you find it under the name monkey, and there are monkeys, but it's just the same. These are turtles. And we had a box of cards and went home, and I tried to solve it. No, I couldn't do that. And I was blamed and said to my kids, well, let's program it. Maybe the computer can solve it. So I wrote a little program and tried it out. And It still works, but I don't have the time to show it. But I give you a comparison. Well, this is the program, and I made so many program applications. You would call it applets now, and you can. Well, you can try. All the arrangements, all the tries, and there are so many. And if you have no piece, there's no problem at all. If there's only one piece, it's trivial. You have only 4 positions to turn it. 2x2 puzzle has already 6,000 possibilities, which is okay. 3x3, 10 to the 11th. So the question is it good? Does the computer program help us? Well, this is just maybe. But if you go to a 4x4 puzzle, it's 10 to the 20, again, order of magnitude. It's too much. But you can buy a fast computer, and it will be okay. Maybe you have several computers in a network in the workstation. Maybe okay. But in general, it's 4 to the power of n and to the times the n faculty. And this is incredibly high. And it doesn't make any sense to start a computer. And this is not a matter of technology. You can wait a year and buy a faster computer. The number, if you have, let's say, 6x6 puzzle, the number of possibilities, I tell you, is far higher if you have a fast computer, let's say with 1 microsecond per trial. It takes several times the time elapsed from the Big Bang, yeah? So it's not a matter, we don't, not only our living is too short, the universe will not exist when we find a solution. So there are things where it doesn't make sense to start, and you got to know that. And I'm very short show you some of the problems of everyday life, which have so many possibilities when it comes to so-called optimization. In most cases, it's a pessimization. When you optimize, you, in many cases, make things worse than they are in the unoptimized thing. But, for example, if you try to put many of these cakes, Christmas cakes, on a plate, you have to arrange them. And there are so many, far too many possibilities that you can't find the optimal solution in a lifetime. If you want to buy fruit, this is a picture from Venice. The fish market has also a vegetable market. And if you want, let's say, you order 1 kilogram, and it should be exactly 1 kilogram. You can pick up some of the fruits, and maybe you start anew with another one to optimize minimize the redundancy. This is our garden. If you want to bring many of these objects, you can put them in order, but it may very well be that another order allows you to hang up one more. Or this is a picture of my garage. If you want to optimize many pieces of wood, and maybe you started with the wrong one, and try another collection, and which allows you to place one more piece. Plausibility is another concept. This is a joke. It's a fake news to collect, to charge you for email, like you're charged for a letter. And if you look at the date, it's the 1st of April, so it's obvious that this is a joke. But if it's not published on the 1st of April, it might be true. So ask about plausibility, ask about significance. I was a PhD student at an institute for numerical analysis, and I had to learn all the numerics. And my boss stated that there more than 80% of all the digits ever computed by a computer are just random because of the numerical errors in computation. I believe that he was completely wrong. It's at least more than 90% of our outcomes. And this is a simple example. An elephant weighs between 100 and 400 pounds, each between 100 and 400 pounds. Pound is equal to, and multiply this, and there's no sense in stating that elephants eat between 10-digit numbers. So this is all garbage. Forget it. Significance. Codes. Codes for resistors, barcodes, QR codes, alphabets. This is all basic concepts of informatics. When I went to China, I had to train to find male or female toilets. And there's the training application in the internet. It's called the Chinese toilet test. The position of 0 in our hand is, it's funny, it's after the 9. This is due to the old telephone impulse coding, and there is a Swedish telephone where the 0 is coded with 1 interaction of the impulse. You see the impulses there. And it's just a matter of code, but not a matter of content. So I give up and just want to come to an end. Algorithms of everyday life. My wife doesn't understand that I am considered, when you move the dishes from the dishwasher to the place where you store it in the kitchen, that I can't do other, because I'm really crazy in that. I try to optimize the effort, and there are two ways, two algorithms where you can choose. You either take the whole bundle of knives and forks, one by the other, and put it on the right place, or, what I prefer, you take the spoons first and have just one movement to place it. Think about it. I'm sorry, I have to apologize. You might be influenced when you leave this room. Stacks and queues. I know people, when they have a stack of plates, who always take, not the upper one, but the other one. So every plate has the same chance to get used. Trees. Relations are so important. I have no time. Abstractions. Determinism. Chaos. Just one word on chaos. But I talked about the butterfly effect. And digital. And acknowledgements. Give me just a second to thank Hans Zemanek, Austrian computer pioneer. And the statement is calendar. It's just information. You want to know you want to predict depending on the culture, the flood of the Nile, or the holidays of Christian, and because on the one hand side, the Earth is rotating on the sun, you can define 1 year, and the moon is rotating around the Earth 1 month, and it's impossible to find a solution to this problem. You have to invent leap years, and you can make the calendar arbitrarily accurate, but also arbitrarily useless. So this is one of the informatics problems. I talked about Edgar Dijkstra. I did not talk about Heinz von Förster. I could tell you a story as well, but you don't allow that. But one of the statements of Heinz is truth is the invention of a liar. There is no truth. Because it's not truth, it's not a general concept. Depends on the observer. what is true and what's not true. And he's also stated, when it comes to ethics, and he's a nephew of Wittgenstein, and told stories about Uncle Ludwig when he came and cited his statements. And the ethical imperative of Heinz von Förster is act always so as to increase the number of choices. George Spencer Brown is a funny man, but I skipped it. What's the hurry? I also cited Joe Weizenbaum. Alan Kay said the best way to predict the future is to invent it. And Alan Perles said, one man's constant is another man's variable. So it depends on the point of view. And I want to end with a problem I couldn't solve. Maybe you can help solving it to me. Maybe you can help me to solve it. The tree of knowledge, it's a catastrophe when you gather knowledge, you are thrown out from paradise. So, is it responsible to teach our kids knowledge and they will lose all the happiness? I don't know. So let me stop with another song of Bob Dylan, and thank you very much. Thank you. It's for the times they are changing.
So, Bob Dylan also wrote.
So, if you can't forget anything, but you remember the Bob Dylan song. That's important.
So, Bob Dylan also wrote, you don't need the weatherman to know which way the wind is blowing, but we were very lucky to have the Java man for that effect today. Thank you very much for me.
Oh, thank you.
Any questions from the audience? Who wants to start?
Thank you very much. I took a lot of pictures.
Okay.
So many nice examples. Yesterday we had this panel about artificial intelligence education. And the more I hear people talking about this urgency to teach AI, the more I have doubts about it. And so I'm wondering, what are your thoughts about it? Doesn't it risk to be the carriage of 20, in the next 20 years? I mean, in the 90s, highlighting text with words seems to be a great technology. Is that so new, is that so urgent, or is it just a product-specific, technology-specific thing?
Well, it depends very much on how you define AI. When it comes to genetic algorithms, I think it's It's nice. It's okay. But it's the technology of the 80s. I had a PhD student in Zurich who made his thesis on the prediction not of avalanches, but of the danger, the degree of danger of avalanches in Davos, on the White Flujoch, with genetic algorithms, neural networks. And this worked excellent, very fine. So it's not new, but it's useful. But I don't want to blame anybody. But you know, Niklas Wirth, the Swiss informatician from the ETH Zurich, who compared, well, I say it, you can't blame me anyhow. He said the relation between computer science and artificial intelligence is the same as between astronomy and astrology. Maybe he's right. I will not comment. Are you happy?
Another question. So if there are no further questions, will you remain available throughout the morning?
For a couple of
so
time,
thank you very
yes.
much again.
May I just thank you for inviting me and for the support. And, well, I want to say goodbye. This is probably my last performance in my life. Thank you. Thanks a lot.